Hello, today I will be exploiting the B-Design website for my CA1 assignment for the module ESDE. In order to perform the first exploit, which is cross-site scripting, I'll be using the register page of the B-Design website, and I'll simulate how an attacker can input JavaScript scripts inside the name and email input fields. So now let's try using John Ross as our sample user. And in this input field, you can include a script tag with an alert that says you have been hacked from the name input field, and we close that up and we do a script closing tag, and we can now do the same. The email section, we can now say John Ross at designer.com, and now we can add a script which says it's all the same thing as the first one, but now we say you have been hacked from the email input field. So let me just copy this later on for the login, and the password will just be a simple password. And now we press submit. It says that we have been registered. Now let's go on to try to log in to prove that this account actually exists. So as you can see, this account exists, and when we go to the profile page itself, we can already see that the JavaScript is running, and here you go. So this vulnerability I'll show you how it will affect the administrator account, which is the main point of this stored XSS attack, because the administrator account, if it is breached, the attacker basically gains administrator access to the B-Design website. So now let me log into the administrator account. So now when we try to search, and let's say we go on and there's not the newly created user that we have just created just now. It's not here yet, but once I press 5, the script will run. As you can see here, localhost, the alert says that I've been hacked from the name input field, and I've been hacked from the email input field. So the name and the email input field are both vulnerable to cross-site scripting. And as you can see here, the John Ross designer just appears as a normal account, so the administrator itself would not realize that he has been hacked. Then also when he accesses to update this user, he will be also hacked. That is all. So now in order to fix this vulnerability, I will be I'll be escaping the HTML text in the input strings. So now let me just comment out both of these. Now I will show you the effect of this code that I've just added. Alright, so now with the added code, I will be able to bypass and I'll be able to solve this cross-site scripting issue by replacing the script text with just an empty string, and therefore the JavaScript will not run in the backend. Now, in order to prove this, I will try to make a new account. Let's say Mike Isaac, and I will add a JavaScript alert box inside the email input field and say you have been hacked, and I'll close it with a script tag, and the password will just be password, and I'll try to sign up. It says that I've been registered. Now let's go to the admin page and see whether I am vulnerable to the cross-site scripting attack. Not. As you can see here, it says that it just prints out the alert and the JavaScript is not executed. The alert JavaScript is not executed, and thus the cross-site scripting attack, the stop cross-site scripting attack, will not work. Alright, so now I'll be exploiting the P-Design website using an SQL injection attack. Now I'll simulate this attack in the login page, whereby I'll try to update Kelly, who is a regular user, to an administrator by changing her role ID. I press submit here, it says that I'm unable to log in, but if we see the workbench, Kelly's user role ID has been changed to 1, which means that now she has administrator access. So now when Kelly tries to log in, she will be instead brought to the administrator page, and now she will be able to carry out administrator functions. She will be able to do all, see all. So that's all. Now I'll move on to the solution of this vulnerability. Now, in order to fix this vulnerability in the login page, I have used parameterized queries in the SQL statement present in the connection.query, and this is to allow the SQL engine to find out which code should be run, and it will not run SQL statements, and it will only allow plain text input into the email field. Now when we try to do the same thing, we try to submit, you can see that Kelly's role ID has not changed, and thus this vulnerability has been fixed. Alright, so the third vulnerability that I have found in the B-Design website is the broken authentication vulnerability. In order to demonstrate it, I will now log into Kelly's account, which is a regular user, and now I will alter the URL so that I am able to access an administrator page. Now as you can see here, I am successfully into the administrator account. I am able to carry out functions to manage users and check user submission, therefore giving me a regular user Kelly administrator privilege. Now, in order to show you the fix for this vulnerability, I will now log into Kelly's page. I will change the URL, but I will not be able to carry out the administrator functions. I've implemented this fix by adding a middleware containing the verify JWT function and verify rule. And as you can see in this middleware here, the verify rule function checks whether the headers in the item in the header, which is the role item, is equivalent to admin or not. And for the verify JWT, it will get the token, and it will check if it's not null, and this thing will run if the token is available. And I've used the JWT function, the JSON web token library, in order to verify the token. And if like the user ID and the role is not authorized through the token value, it will send 403, and it will not allow access to those functions. Now I'll be showing you the broken access control vulnerability in the B-Design website. When we log into Kelly's account and I change the user ID in the local storage and I refresh the page, I'm now able to access Elon's account's designs, and essentially the system thinks that I'm in the Elon's, I'm logged in as Elon. This shows a very serious broken access control flaw. In order to fix this flaw, I have slightly edited the check user function middleware, whereby I will check if the real user ID in the JW token is equivalent to the user ID in the user body, which is the local storage. And I've done that by using the JSON web token library, and I verified the token with the secret key provided in the env file. And now when I try to, let's say, log out, now I try to log back in Kelly's account, password, Here we go, I can search. Now when I try log in 202 and I try refresh, I'm unable to search. I'm also unable to manage my own designs. So this is the fix for the broken access control vulnerability. Now in order to prove the next vulnerability, which is sensitive data exposure, I'll be using Burp Suite and the Foxy Proxy Firefox extension and also the Firefox browser. First, I'll turn on the proxy and I will try to log into Kelly's account, and I'll turn on the intercept in the Burp Suite. And now when I try to log in, as you can see here in the packet, my password as kelly@designer.com is not encrypted at all. The password is available in plain text and thus proves that there is a sensitive data exposure in the B-Design website. Now, in order to show you the fix for this sensitive data exposure, I will now try to log in back again, and as you can see, my password has been encrypted. This encryption is done by using the crypto.js npm crypto.js JavaScript library, which encrypts any plain text using whatever standard that I would like. So in this case, I've used the AES method of encryption, which is a reputable method of encryption. So I will do that. I'll do the encryption in the login.js file in the front end first. And then as the password moves along in the packet, because in sensitive data exposure, we have to check whether the sensitive data is available as plain text at rest and in transit. So this is to fix the sensitive data exposure at rest. So I encrypt the password, the front end. Then as it goes on to the back end, the password is decrypted using the same crypto.js library. And I decrypt it, and then I compare the decrypted password as per normal. So this fix allows us to encrypt the data at rest. And I've also applied HTTPS. I've made my localhost HTTPS in order to make sure that the data that is in transit is encrypted at all times. So this is a solution for the sensitive data exposure flaw. Alright, in order to prove the final flaw, which is the insufficient logging and monitoring flaw, I will have to use Google Chrome, and now I will try to inject an SQL statement, but I have already fixed the SQL injection vulnerability, so this won't actually work. But it's just to show you that an attacker can inject this statement, but this vulnerability will not allow the website owner to see that his website is being attacked by an attacker in any form or manner. So now I'll try to log in, and unable to log in obviously. But when I go and see my log, there is nothing. Like there's no any log that shows that this attacker is trying to conduct SQL injections on my input for the login page and stuff like that. So this is obviously a flaw, and we should fix it. Now, in order to fix the insufficient logging flaw, I am using the Panya logger, which will create a very verbose logs on the action done on the website. So now when I try this again, sorry. Now when I try this again, it says that I'm unable to log in. But as you can see in the logs here, as the owner of the website, I should be able to see the content that is uploaded into the input fields. As you can see here, kelly.com, update user set role ID where email equals to all this. I should be able to see this as a website owner, and now I realize that there's someone trying to inject SQL statements into this input field. So now I will know that let's say someone actually manages to inject inject SQL statements into this input field. I'll be able to know as a backend user, and I'll be able to quickly patch it up and reduce any damage done by the SQL injection, and also fix and also prevent the same method to be done on that input field. That is all for my ESDE video. Thank you for watching, and goodbye.